Okay, what do you guys have for this first one? What did you need for our chemistry definition? Say again? Okay, there's 2 points to it. We're going to have something about studying matter.
Electron actions.
Yeah. The studying the property of matter is kind of obvious, 'cause we want to study their density and luster and all these other electrical properties associated with them. But why the electron stuff? Why is that important?
This is how it's an interaction with other substances.
Yeah, every interaction that you see is a chemical interaction that's happening because the electrons are doing something. So when we're talking about chemistry, we're talking about two things. We're talking about the staticness of some things, like metal conducts electricity. Okay, great, that's a thing. Windows are made out of silicon dioxide and they're transparent. That's a static property. But then we're also talking about, well, what happens if I take a window, the silicon dioxide from a window, and interact it with hydrofluoric acid? Then there's some electrons start transferring and I get some action going, and that window goes from being nice and clear to being like a bathroom window, being opaque. You can't see through it. Okay, how do we want to subdivide matter? That's a sub for sure. So we can go homogeneous and heterogeneous, but that's a part of something else, which is what?
Pure substances and mixtures.
Okay, so this right here, these are mixtures. And then we have pure substances. And inside of pure substances, what do we have? Okay, so a super easy example of a pure substance would be table salt, NaCl. So why is NaCl not a mixture?
Because Na and the Cl are chemically bonded.
Okay, anything else? If I give you a salt shaker and it's just got regular table salt in it, it's just NaCl, and it's NaCl throughout the entire thing, right? There's no other stuff, so it's not actually a mixture. Sure, it's a mixture of sodium and chloride, but they're chemically bonded to each other. They can't be separated out by physical means. So you can have more than one thing, it's just, are they chemically bonded to each other or not? And then I can break that compound down into the elements. So your basic, most pure thing would be the elements. Mass and weight, how do those two guys differ?
Mass will always be constant. Weight depends on gravity.
All right, this is this, you could say that this is that weight is dependent upon position. You okay with that? So what's a super quick way to lose 3 pounds? Fly to Denver. Done. I just lost 3 pounds. Am I any healthier for it? Of course not. The same mass of me is still there. I still have the same amount of all the different types of molecules, but I lost 3 pounds because I got further away from Earth. What's a quick way to gain a half a pound?
Fly to Seattle.
Fly to Seattle. We're only like 500 feet above that. How about Death Valley? Go to Death Valley. Why? Lowest point in the United States. It's below sea level. You'd actually gain weight. Your scale would register a higher weight. You haven't changed at all, but you're closer to the center of the Earth, so the gravitational pull is tighter on you, so you weigh more. But your mass is exactly the same if you're Denver, Death Valley, or sitting here in Hood River. Okay, this next one. Which ones of these are we going to circle?
All of them.
All of them. So just like English, like you can say stop like 9 different ways. In English, math, you can say the same exact thing many different ways. So all 4 of these things are exactly the same thing. So I'm going to take this density equation and just rearrange this, and so I get the volume is equal to the mass divided by the density. And then if I rearrange it again and I solve for the mass, I'm going to get the mass is equal to the volume times the density. The math in here isn't actually going to get much harder than that, honestly. It might feel like it, but it actually won't. Give me a couple of examples of pure substances.
We don't have that.
Those questions.
Cool. You don't have that question?
That was
Oh.
the last one.
Yeah.
This density one was the last one?
Yeah.
And why are you in this class?
And while you're in, Awesome. All right, well, I guess it didn't upload. I added some questions to it, but all right, no worries. Somebody want to give me an example of something that's pure?
Water.
Okay. H2O is a compound. It's a pure substance. Something else? Anything off that periodic table, right? Because all those things are elements, so we could just say carbon. How about an example of a heterogeneous mixture?
Like a bowl of assorted nuts or something.
Sure. Mixed nuts. Excellent. Something else? How about paper? Is paper a heterogeneous substance? You don't think so? If you look really, really carefully at this paper, it looks exactly the same all over the place, or does the color fade just a little bit from spot to spot? Maybe you can see fiber in it, especially if you get like recycled paper, then you definitely see the fibers in there. But if I look at this really carefully, it doesn't actually look the same all the way across. And then this one is absolutely heterogeneous, right? Because there's writing all over it and there's ink on it. How about homogeneous?
Coffee.
Coffee. Perfect. Anything else? Where do you see that word in the grocery store?
Milk.
Milk. If milk isn't homogeneous, you probably don't want to drink it. It's either gone bad or it was never homogenized. So why does milk need to be homogenized? What is in milk? There'll be some bacteria, sure. What else? What are they?
Lipids, fats.
Fats, absolutely. And then anything else in milk?
Proteins.
Blood? I hope not. A little bit? Oh, I don't want to know that. Don't tell me that. What's in the actual milk that comes out? Proteins. So those two things don't like to mix together with each other. And the main component of milk would be what? Water. So do the fats and the water want to mix together? Mm-mm. So what you need to do is you need to shake the hell out of it and usually add a little tiny bit of a molecule called lecithin. And lecithin is a lipid that allows things to be homogenized. Lecithin is what makes mayo look like mayo instead of egg white sitting on top or sitting below some vegetable oil. All right, and then I'll read this last one. Okay.